Hello, I'm Jacob, and this is the testing video for my plant monitor system design project. My design project focuses on developing an Arduino-based plant monitoring system controlled in real time through the online IoT interface Thinger.io. With integration of sensors for measurement of room light intensity, temperature, humidity, and plant moisture levels, as well as a watering system, this plant monitor will efficiently enable easy monitoring of any plant within a household while being able to be watered in a timely manner. Here's a circuit schematic for the plant monitor system design. Here we have the Arduino Uno R4 header connections. Here we have the soil moisture sensor connected to 5 volts ground and analog 1 pin of the Arduino. Here we have the temperature and humidity sensor connected to 5 volts ground and digital pin 2. The 5 volts and digital pin is tied to a 4.7K resistor. Next we have the light intensity sensor, which is connected to the SDA and SDL analog pins as well as 5 volts and ground. Here we have the relay module, which is connected to digital pin 4 of the Arduino, which is connected with a transistor, a freewheeling diode, and the relay. The relay is then connected to the water pump as well as an external 9-volt battery. Here's the final Arduino code that will be used for the plant monitor system. Since the last update, the code now converts some of the sensor readings to percentages, ensuring accurate data is being sent to the IoT dashboard. Since the last update, the plant monitor system has been implemented onto a custom PCB shield, which was made through KiCad that mounts on top of the Arduino. The PCB shield was developed following the circuit schematic that was previously shown, with all sensor connections being connected through header pins, and an onboard relay module has been implemented for the use of the water pump. The sensors that are featured on the system include a DHT22 temperature and humidity sensor, a capacitive soil and moisture sensor, a BH1750 light intensity sensor, as well as a water pump system connected to the screw terminal on the board, which is connected to the onboard relay module. The Arduino is powered through a USB-C cable, as well as a 9-volt battery is included connected to the PCB shield for operation of the water pump. When the plant monitor is turned on, the sensor data readings are displayed onto the Thinger.io dashboard in a graph and gauge format. There is also the option for the user to control when they want to water their plant. By turning on the water control option, as seen here, the device turns on the water pump, watering the plant. I varied some of the sensor readings here to show that the interface accurately displays each sensor reading in real time. The newest addition to the dashboard since the last update includes a gauge that displays the sensor readings, with the gauge changing color depending on if the sensor reading is good, corresponding to color green, or concerning for the plant's environment, indicated by a yellow or red color. This feature is further tested upon in the testing section of this video. Here's a clip of the constructed plant monitor system with plant. In order to calibrate the sensor readings and the IoT dashboard, testing was underwent to ensure all data readings are displayed accurately so that the plant's health is good and maintained under every possible environment it may face. In this section of the video, I will demonstrate how I tested the temperature and humidity sensor, the soil and moisture sensor, the light intensity sensor, and the water pump. To test the temperature and humidity sensor, I used a lighter to increase the surrounding temperature and humidity of the sensor. This resulted in the sensor readings being accurately displayed on the dashboard and the gauge color becoming red, indicating a harmful environment for the plant. To test the light intensity sensor, I used an LED flashlight to increase the surrounding light intensity. On average, the light intensity of a house plant to be considered healthy should be around 1000 to 4000 lux, so any light intensity reading above or below that range is considered harmful for the plant. This test resulted in the sensor readings being accurately displayed on the dashboard and the gauge color remaining green, indicating a healthy environment for the plant. To test the soil moisture sensor, I used various dry and wet test environments to calibrate this sensor. I first placed the sensor in the water pump jug, then in the plant with dry soil, and then in the soil after being watered. This testing is shown here. This test resulted in the sensor readings being accurately depicted on the dashboard and the gauge color becoming yellow, as expected. Finally, by turning on the water control option, I tested that the water pump waters the plant as expected. This is the 3D printed enclosure I designed for the plant monitor system. Note that this was the first prototype of the system's enclosure, which will now be redesigned due to cracking in the pegs that the Arduino mounts onto. And here's how the plant monitor system hardware is implemented into the enclosure. Thanks for watching. Stay tuned for the next video for this project.